Greetings. This is Rob Sabourin, and I'm making a short presentation about the subject of staying relevant in test leadership. So a lot of people ask me about how do I stay relevant? How have I stayed relevant? I've been involved in software engineering from all perspectives since the early 1980s. First commercial release, June the 4th, 82. Still actively practicing software engineering, working with some of the biggest software projects on the planet these days. And I'm trying very hard and continue to try very hard to stay relevant in test leadership. So I guess the question is basically, what is the topic of today's chat? So I want to help people learn how to be relevant amidst the tides of change. We are in a highly turbulent universe, and basically I want to help people tame chaos, tame turbulence, and tame confusion. Helping people adapting to new contexts in business, technology, organizations, and culture around us, and provide you a bit of guidance based on my experience. I want to share with you how I've done it, not necessarily maybe what you should do, but hopefully giving you some ideas from my experience. Let's talk about the big one today. Everybody, this is the date today, by the way, it's October 2024, and everybody's constantly talking about AI. How can we deal with AI? As if AI is a new and emerging problem. Well, let me give you some examples of the changes because of artificial intelligence that I've been involved in directly. So from 1997 to 2000, I was involved in medical diagnostic medicine, software to do diagnostic medicine. I set up software engineering processes, testing teams, worked on projects, got things done, kicked butt, did a lot of great work in that period of time. And everything we were doing was using what we called inference engines, which was the AI of the day. And we basically combined clinical observations, lab results, medical knowledge bases, and dealt with the patient at the point of care. We had to learn about relational knowledge, learning from patient history, and we had systems that were built by experts. We called them expert systems. They were used in diagnostic medicine by clinicians at the point of care to help diagnose people. Basically, this software had to work well, or people could be misdiagnosed, which could lead to incorrect treatment, drug interactions, or in the worst case, someone could actually die from a misdiagnosis. So we were fanatical in figuring out how the heck can we test an inference engine, a machine, an algorithm that's doing diagnostic medicine. So in order to test this, we set up mechanisms to do validations. We did not necessarily trust the systems that were generating the medical knowledge and doing the diagnosis. So what we did was we came up with a mechanism where we built a repository of validated knowledge. We did this on a per change basis to our knowledge base. So whenever there was a change to our knowledge base, a delta, a new thing added, an old thing changed, a new factor considered, we basically would hire 3 independent domain experts. So if there was a certain type of medicine, I would hire 3 people who were usually practicing doctors in the field of the specifics of the knowledge base. The 3 independent experts were hired through companies in other parts of the world, and we made sure we had variety of people from different places, and we basically asked them, we gave them the diagnostic challenge, and we asked them to see what their diagnostic was without showing them what the software was generating. Then we basically compared the diagnosis from the 3 domain experts with the diagnosis of the software to make sure that the match was reasonable. From a medical perspective, I cannot tell you what reasonable was. We had actually doctors helping us determine if they were reasonably close, and if they were acceptable, then we would say that has been validated, that medical knowledge is validated, and we would trust it. But if it didn't, if even one of the 3 disagreed with it, then we would say we have to change the knowledge base, or we have to change the way that we're testing the knowledge base. So validation required 3 independent domain experts for every delta every change in the knowledge base. And we were fanatical about this, and we did this quite well. And I worked in this area for 3 years. It was fascinating, amazing thing to work with basically diagnostic medicine from a medical inference engine. That was AI, 1997-2000. Now, from 2000 to 2002, as an independent consultant, I had an opportunity to work with some teams of people who were doing voice processing, basically machine understanding of human voice. And this was done at the time with what was called neural network technologies, which basically from 2000 to 2002 were basically taught. We had to teach the system, and the system configured itself based on learning stuff using pattern matching algorithms and technologies. We basically built a network by correlating vast collections of samples. So there were samples, tons and tons of samples, which we knew what the expected result was. And we built what was called the regression training of the network. And we had to come up with very novel ways to assess correctness. And we did this with some voting schemes. So we had domain experts vote on the results to see what the expected result should be from the voice sample. And we would grade it as saying, is it the same as the previous? Is it better than the previous? Or is it worse than the previous? And of course, in regression testing, we had to always get better or the same for the voice recognition. And the voting on this, of course, was done using automated tools we set up for a large part. However, human beings had to say, hey, was this correct? Someone had to actually validate that. So that was neural networks for voice recognition I suppose that was the early days of voice recognition, but this is all artificial intelligence. No one thought you could actually do this. And the regression testing was beautiful and drove development. A lot of the testing on this project drove development. And when we learned how to test it, we also taught people how to configure and improve the system. Now, recently, from 2022 to present, I've been working on generative AI, and I basically have used generative AI to help me develop data integrity test algorithms, which I consider a major problem in software testing these days. How do we test data integrity? And I developed algorithms, and I used generative AI to help me generate the algorithm. Now, I knew a lot about how I wanted the algorithm structured, and it was generative AI that just basically helped me with the syntax really and structure of the programming for this. The algorithms we used were data traversals doing checksumming with a masking of fields that had certain attributes to them so that we would get consistent checksums. This was just a beautiful algorithm that was put together with using generative AI, so I learned a lot about generative AI to do that. I basically decided that it's very important for me to at least learn how to test and learn how to use generative AI in testing. So I basically set up a group of people, a peer community that meets actually pretty much every week for 1 or 2 hours, and we actually look at interesting problems and how they're solved in using generative AI to test other systems, but also in testing generative AI. And of course, there's no magic solution to this. It's an interesting problem space, and I'm learning more and more that my fundamentals in statistics, for example, are helping me in setting up really interesting experiments to help validate generative AI systems. It is a really rich and complex problem space. I used it also to come up with test ideas using my just-in-time testing approach, and basically we set it up so that the generative AI would basically be trained from information we put together, including formal software requirement specifications, process block design diagrams, usage scenario summaries, and failure mode effect analysis tables. We trained the AI with that, and to validate it, we basically compared the assessments that the generative AI gave for the testing of the system with those test ideas from independent experts. We got a lot of, so far, the state today is we're getting a lot of interesting, great testing ideas. Very few, though, are new testing ideas, and we get a lot of hallucinations, which are actually things that seem to be test ideas that are being made up by the generative AI out of nowhere. So we don't like the hallucinations, and we feel that would be a distractor for any professional testers trying to use this system. Anyhow, all of it looked credible. How do I learn? I learn by meeting with peers and trying to solve real problems with real systems as we go. So generative AI is just an example of learning. I've been adapting to things forever and for always, though. There's always new technologies. And so to learn, I basically learned to share first-person experience and to learn from people's first-person experience, not from some abstract theory, not from some cookbook on a YouTube video. I want to hear and talk to people, listen to them. I want to hear the first person, I want to hear what they did. They want to use the word I when they're describing to me. I did this, I did that, not I read about this or someone else did it. I want to know what worked and what didn't work. And this is like show and tell. So frequently, let's share with others what we're doing so that we can learn. Try to keep it short and sweet, like be able to do a talk in 15 minutes or less, as I'm trying today, but do it frequently. Not just once a year, but frequently, every week, every couple of weeks. Do it. Figure out a way to share experiences in the first person frequently. Share what you're doing and share, have other people share with you. Of course, keep trade secrets secret, but share your learnings and how the learnings are applied, basically by building a collection of what I call fieldstones that ultimately will be a bunch of exemplars that we can learn from and share and apply to other projects in the future. There's always innovations, always, and I suggest you innovate. As part of your testing, innovate all the time. Each iteration, each time you work on a new project, a new product, a new iteration, every day, innovate. Take baby steps, adapt as you go, tweak as you learn, and pull back if it does harm and it doesn't work. Be tenacious. Always try something new. Always adapt something to new technology, new methods. Always consider alternatives. So one of the most important things to stay relevant in test leadership is to always innovate. In terms of your team, I'm a big fan of building teams that are able to adapt and learn and innovate. So basically, I try to make sure I surround myself by teams of people who love to learn. I want to foster a spirit of excitement when we have novel solutions. I want to encourage people to continuously be educated. Every team member, when I hire them, I make sure that they, on an annual basis, go to at least 2 learning events, one job-specific, one domain-specific, and I also support continuous education, especially at post-secondary university-level courses in whatever they're interested in learning. I support academic education, and I never stop encouraging people to learn how to apply fundamentals. Take fundamental principles and apply them to new problems. Don't forget your fundamentals. It's important to get a diversity on your team. People who learn things differently, have different life experience, different interests, different education. Make sure you have variety of contexts. People who have worked on different businesses, different technologies, different organizations, different cultures, and make sure that they learned it independently. Don't get everybody from the same team, from the same project. Get as much diversity as you can in the team. And that, for me, helps me to stay relevant in leading people by having teams that have diverse skills and experience and love to learn. But keep in mind, there's some direction and there's some misdirection. Some innovations do not stick. Some technologies become dead ends. Think of Ada, Object Pascal, and Palm Pilots. These are all technologies that when they came out, people thought they were going to change the world, and it works out that they didn't. Now, they're still used in some places, and they still have value, but they never achieved the technological dream they had. Some methods are bogus. Some advances move you backwards instead of forwards. Some crystal balls to see the future are very, very foggy. Some flavors change every month. Some tools fail to solve your problems. Some solutions cause new problems. And some learning can be treated like play in disguise. Think about a spike on an Agile project. Turn learning into a fun activity. And keep in mind also that some opportunities to learn are short-lived. So keep your eyes open for opportunities to learn and take advantage of them when they present themselves to you. These are some tips on staying relevant in test leadership. I think that you should always try to learn new things, and every single opportunity you have, apply it to a project and learn from people's real first-person experience and share your experience with others as much as possible. Anyhow, that's it for me. It's a short presentation. I hope you got some tidbits from this. Take care. You can always reach me at robsab@gmail.com. Take care. Cheers.